Please write the first point. People taking lots of salt experience water retention in tissues and intercellular spaces resulting in puffiness and swelling. This is called edema. This is called edema. Okay. Write this down. You will understand how this happens. Okay. So why the people who take a lot of salt experience water retention in tissues and intercellular spaces. So when water is retained in the body, obviously that body part of that body or then those tissues, they will swell a bit, right? Now, why does this happen? Let's suppose this is a normal tissue. This is a normal intercellular space. And this particular cell, almost complete body, we remove the skeleton. And even if you look at organs, most of the things, like our body is mostly liquid. Okay, it is mostly liquid, even though what we see is solid, but inside it we have mostly it is liquid. Like with the maximum amount of like water is present. I know, not pure water, but water. There will be some water in blood. There will be some water in the different fluids that is present in different glands. Okay, so water is always present. So whenever you have a solution, not pure water, obviously you are going to have a kind of solution. Each and every solution will have its own vapor pressure, a normal vapor pressure that is to be maintained by those cells or tissues. Now, the people who take a lot of salts, what will happen? So we have a normal vapor pressure. The people who take salt, they will experience a lower vapor pressure. Why would they experience a lower vapor pressure? We have seen this in relative lowering of vapor pressure, that whenever you add a non-volatile solute, then the vapor pressure of the solution, it is going to decrease because the solute particles, which is solid, they will acquire a surface. They will acquire the surface positions, and they will not let the things evaporate. Okay, so each and everything will have their normal vapor pressure. People who consume a lot of salts, they will be having more solute. That is why their vapor pressure will be lower. In order to get the lower pressure to the normal vapor pressure, to get the lower vapor pressure to normal vapor pressure, what we need to add? We need to add more solvent. And if you increase the amount of solvent, then what will happen? Those solvent molecules, they can vaporize and form a normal vapor pressure. So in order to go from lower vapor pressure to normal vapor pressure, this is normal. What we need to add? We need to add solvent, and the most important solvent, or the solvent that we have in our body, is water. And that is why what is going to happen? Go from here to here. What we have to do? You have to add water. And when you add water, then what will happen? They will become puffy. Bulky ho jayenge. They will become puffy. And there will be swelling. And this particular disease, it is known as edema. Is this clear?
Yes, sir.
Don't need to write this.
So what is it called?
Edema. EDMA.
Edema.
Edema. For our purpose, EDMA is more important than the pronunciation. But since you asked right now, this is how my teacher pronounced it, edema, and that's how I am pronouncing it. So I don't really know if this is the correct pronunciation, but it feels edema is fine. Okay, so if you get a more correct pronunciation, you let me know, Abraham. Okay.
So no issues. I didn't hear the word. That's what I was.
Yeah. Since you just asked, it struck my mind. Like, why I'm pronouncing this edema? I'm pronouncing it because my teacher, like I had a teacher, and That teacher had a teacher who used to pronounce, the teacher is talking about a chemistry teacher. So my teacher's teacher used to pronounce this as chemistry, not as chemistry. He used to pronounce it as chemistry. Now, right now we have internet and everything, so we can hear the pronunciation of each and everything. But whoever introduced chemistry to that particular person, they would have pronounced it as chemistry. That is why that person is also pronouncing it as chemistry. But later on, people came to know it is not, it is actually chemistry. Not people, like my teacher came. Okay, moving on. Yeah, next point is salting in meat and adding sugar in fruits results in loss of water and bacteria dyes. Now, when we make any pickle, okay, if you want to make a pickle or jam, there are two things. So if you want to make pickle, what do we add? We add a lot of salt and we add a lot of oil also. Now, what does oil do? Oil creates a barrier between the pickle and the oxygen. That is why it will not get rancid. The salt, what does it do? When you salt, first of all, you salt it and then you dry it. When you salt something, all the water will come out. Now, those who have made salad in their home or they know how to make salad, what we cut it each and everything, and we wait for the time in which we are going to have lunch or in which we are going to have dinner. Just before lunch or dinner, we are going to add sugar. So you try to, I mean, if you have observed this, then well and good, but try to observe this thing. Amarnath, Sufyan, and Mariam Batu. जब भी डिनर लगेगा ना, लाइक अगर मेहमान आए हैं तो डिनर के जस्ट पहले ही उसमें क्या किया जाता है, सॉल्ट डाला जाता है. व्हाई? बिकॉज इफ यू ऐड सॉल्ट वेरी अर्ली देन ऑल द वाटर विल बी रिमूव, है ना. एंड दोस like if you have carrot or radish or anything else, those will become very loose. And the pleasure of eating salad is that type of thing that should come, like when you are eating, then only it looks like it is fresh. Right. So what happens with salt? Salt, when we add salt, it results in loss of water. Loss of water is because of osmosis, because let's suppose this is some fruit or vegetable or meat, anything else, whatever you want to think about. If you have added salt, then what is going to happen? On the surface, the salt will be there. Now, in the surface, we have salt, and inside, actually, we make surface. So here we are having salt, right? Here we are not having salt. Beneath the surface, in the bulk area, we are not having salt. So the tissues which are present or the cells which are present on the surface area, they will have lower vapor pressure. They will have lower vapor pressure. This will be having higher vapor pressure. Why? Because here we don't have any salt, we don't have any solute. So the inside will be having higher vapor pressure. And what will happen to the solvent molecule? Solvent molecule will move from higher vapor pressure to lower vapor pressure. So what will happen slowly and slowly, all the water from the bulk, they will rise to the surface. As they rise to the surface, if something is on the surface, they have come out of the bulk. So this is how the loss of water takes. Now, how does bacteria die? Obviously, each and everything, like bacteria would need water to survive. And if there is no water, the bacteria will die. So what do we do? Like whenever we have some cut marks, so we first of all clean that thing with spirit. So what does spirit do? It dries very quickly. If you have seen any hand sanitizer, so hand sanitizer, it will dry up your skin or dry up your palms very quickly. So that's what we do. We add or we clean everything with spirit, and that is kind of like an alcohol. So this is what one of the applications of osmotic pressure, right? So we have seen two
So you're
applications
not
of
audible.
osmotic pressure. I'm not audible at all.
It's very faint.
What about now? Is it fine now?
It's better.
Is it any better? It's better.
Yeah, it's better.
So did you? I hope you wrote this down. If you have not written, please write it very quickly. And then we are going to talk about reverse osmosis. reverse osmosis. Here also we are going to write things first and then I'm going to explain it. Okay. But also now one more thing that I would ask is that try to understand while we are writing itself. You should not be just writing the words, you should be understanding the meaning also while you're writing. So please write with me the movement of solvent through the movement of solvent through SPM from a solution of higher concentration that is impure to lower concentration that is going to be pure. Higher concentration to lower concentration by applying external pressure on the impure side, on the impure side. On the impure side is called reverse osmosis. It's called reverse osmosis. Write this down. Let us write one point, that is the semi-permeable membrane that is particularly used in the ROs. We can write this point. Cellulose acetate. Cellulose acetate is used as semi-permeable membrane in RO, in reverse osmosis. Okay. Now, let us understand how is this happening, why is this happening. Now, let's look at this particular code. We are first of all going to take the normal condition, then we are going, first of all, we are going to talk about osmosis only. Right? I will remind you guys what is osmosis, and then we are going to look at what is reverse osmosis. So here we are having fresh water, here we are having salt water. Okay, fresh water and salt water. So obviously this is lower concentration. The fresh water will be not having any solute molecules, right? Will not be having any solute molecules. This is lower concentration. And the salt water, it is going to be higher concentration. So when will happen, the osmosis will happen from lower concentration to say higher concentration. But what we do is we add a pressure. Okay, we add a pressure on what, on the higher concentration part, on the higher concentration compartment, and that pressure is higher than osmotic pressure. It is higher than osmotic pressure. So when, what is osmotic pressure? When the vapor pressure is made equal for fresh water and salt water, that is osmotic pressure. उससे ज़्यादा अगर कर दें, what happens when osmotic pressure is applied here? Stop. This osmosis will stop. But if I apply a pressure that is higher than osmotic pressure, I am just reminding you guys what is osmotic pressure. Osmotic pressure is the pressure needed to stop osmosis. If I am going to apply higher pressure than osmotic pressure, then reverse osmosis will take place. Rather than going from fresh water to salt water, what will happen? Water will move from salt water towards the fresh water. And why is this helpful? It is helpful because the salt water is going to contain impurities, but the impurities are not going to pass towards the fresh water, only the water. The pure water is going to fall, or it is going to move towards the fresh water. This is how reverse osmosis works. You want to write the, you want to draw the figure, please draw it. So please raise your hand once you're done. Just give me a second. Just write a small question, then we move forward. Calculate the osmotic pressure. Osmotic pressure in pascals exerted by a solution prepared by dissolving 1 gram of polymer, 1 gram of polymer of molar mass, 185,000 in 450 ml of water, 450 ml of water at 37 degrees Celsius. At 37 degrees Celsius. Okay. Don't worry. I will tell you how to solve it. You just need to do a bit of calculations, nothing much. Let us see. So they are asking us to calculate the osmotic pressure. Fine. So as this is how you need to read the question, sir. They are asking us to find. Okay. In pascals. Okay, fine. We have to calculate this in what? In pascals. Okay, in pascals. Exerted by a solution prepared by dissolving 1 gram of polymer. 1 gram of polymer. That means the WP is equal to 1 gram. Of molar mass, they have also given the molar mass that is equal to 185,000, right? 185,000 is the molar mass of, and the given mass of solvent, it is equal to 450 grams. So, sir, it is given ml of water, but you're writing grams. Yes, because the density of water is 1 gram per ml. Even you don't know this, but the questioner, like, even I will expect that you will not know this or you will not know this, and it will not strike in your head very quickly. But the questioner always expects you to know the density of water. Okay. For example, the questioner can expect you to know the boiling point of water. Right? So if there is some use of boiling point of water in the question, then you would be seeing, sir, but you have given data. So, similarly, freezing point of water, you should know this. And the questioner can expect you should know the freezing point or the melting point of ice, freezing point of water. Similarly, the questioner also expects you to know the density of water, that is 1 gram. Okay. That is WA, which is equal to 450 grams. Another thing that they have given us is also the temperature. So let me just make space. Now, whenever you write temperature, especially in chemistry or any sciences, the temperature should always be in Kelvin. So 37 plus 273, you don't have to even calculate it. It is going to be 310 degrees. Right? 310 Kelvin. Now, we know the formula that phi, it is equal to C into R into. Now, what is C? C is going to be the number of moles of solute divided by the volume of solute. So they have asked for the volume. I have asked the volume to 450 ml will go. Volume of the solution into R. Now, here comes the difficult part. So, what should be R? What should be R? So, the values of R, I have told you guys there are two values. The two values of R I must have told you guys. R is equal to 0.082 liter ATM per Kelvin per mole. Another value of R I would have told you 0.083 meter bar per Kelvin per mole. Fine. Now, 1 bar, it is equal to 10 to the power 5 Pascal. Okay. So what we are going to do? Okay. What we are going to do is, ये bar को हटा के क्या लिखना है? Pascal. Fine. I need to remove this bar. Fine. If I want to remove this bar, I have to multiply by 10 to the power 5. This R value will become 0.083 meter. Okay, 0.08 meter. Instead of bar, I can write 10 to the power 5 Pascal per Kelvin per mole. Basically, it is 0.083 into 10 to the power 5, and the units will take care of itself. We have done the part where we need to what we do, take care of the units, and we have taken care of the units. 10 to the power 5 we will multiply. That is R. You must know that 1 bar is equal to 10 to the power 5 Pascal from physics, maybe. If you don't remember, you must have heard this, right? Or no? 1 bar is equal to 10 to the power 5. You must have heard. That's right. So for R, I will write 0.083 into 10 to the power 5. And for temperature, I am going to write 310 Kelvin. Now for number of moles, I can write 1 gram, that is the given mass, divided by the molar mass, that is 185,000, multiplied by the volume. So by the volume should be in liters, volume should be in liters, I will write 0.45. 450 ml. So you will say that it is only water, not solution. So if you add 1 gram anything in 450 ml, that is not going to increase or decrease the volume of the solution in a significant manner. Huh? 450 का 450 ही के करीब रहेगा. It will be 450.1, 450.2, 450.7, something like that. But it is not going to make a significant change if you add anything of 1 gram. And in the numerator, I can write, remove this one, and it will be 310 multiplied by 0.083 multiplied by 10 to the power 5. I'll try to solve this. I can do some approximation. आप अपना solve कीजिए. I will do some approximation. This will be 850 and then 2 zeros, I guess. And 185,000 and 0.45 is very near to 5. So this value will be 500. I'm doing approximations here. It will be 9. 2, 5. There will be 2 zeros, I guess. Okay, so this value is a bit more than the real value. Because what I did is I did not multiply it by 0.45, I multiplied it by 0.5. So what will happen? It will become half. So 185, and we are having only 3 zeros. So this will be 9, and 5,000 का कितना जगह? So this will be the half of 89. So since I am multiplying by 0.5, whatever I am getting, whatever the value I am getting, it will be a bit more than the real value. It will be a bit more than the real value. And if I give them equal zeros, I can even further approximate it as 31 into 8300. Or one more zero, here it is again. We are having 92500. It will be slightly less than 31 only because quite 8300, and whatever that in the denominator, it will be less than 92500. So approximately 30 के करीब आंसर आना चाहिए. Try to calculate it. It will be approximately 30. we're having 83000 divided by 92500. This is 0.89. 0.89 multiplied by 31. It is going to be approximately 30 gets 27.8 hours. Yeah, so 27.8. And if I not the real value, it's a bit. So that's what I can tell you. Let me use the real
But you said the
value.
it's dissolved in 450 ml of water.
It's dissolved in
450 ml of water.
correct.
So won't it be wait, this is this.
Sorry, what was not?
No, so sir, I'm getting 1.4 into 10 by 2.
No, but till where is it same? Like we have done till here at least. Is it same till here?
Sir, I didn't approximate. So,
So it will be same till here. Till here it is same, right?
uh, somewhat, yes, sir.
Let's see. No, somewhat क्या पूरा same होगा ना? लेकिन
Sir,
क्या आराम से देखो.
I cut the temper 3 of 185 with 0.450.
Wait a second. So we have written this as P10 into 83 into 10 to the power 5 divided by 185,000 multiplied by 450.
Uh, into 10 power minus 3.
Why?
So because it's 450 ml, right? And it should be in liters.
But you have removed the decimal from the 0.083 also, no?
Yeah.
0.083
Yeah,
divided
same
by
thing, same thing. Yeah.
0.50. No. But what did
Yeah,
you
yeah.
do? आपने
Sir,
सिर्फ ये
I wrote 310 into
हाँ tell me ना
83 into 10 by 2
no wait
by
310 into no 310 into tell me the numerator first of all the numerators 310
310 into 83 into 10 by 2.
into 10 to the power अच्छा you did that thing here okay fine makes sense ठीक अच्छा no so if the numbers are same then it will not be
No, but I'm getting a different value for osmotic.
310 multiplied by 0.083 multiplied by let's leave that part. And what we can do is
Let's try again.
we got 5.3 multiplied by 100 equal to this 185 into 0.4. This will be 30.9. This will calculate कीजिएगा सही से because यहाँ पर थोड़ा दिख रहा था. This value will be this denominator will be a bit more than this. Whatever we have got, it is a bit more than the real value. So the real value will be a bit less. The real value will be less. And if the real value is less, that means these two numbers can cancel each other approximately. Okay. Even though it seems like it is very far away, but these numbers can cancel each other. And
so
we get the value as 30.
I got 30.9.
30.9, 39.9 is correct. If you multiply 185,000 into 0.45, you get this value,
Yeah.
Get this value as 83250. So 83250 is very close to that 83000. So 83000 and 83250, they are very close. We can cancel this and the approximate answer will be correct 31. You can even write 31 itself. Mariam Batul, am I audible? Yes, am I not saying something? Am I not saying something?
Yes, sir. Yes, sir.
Where you seeing something? Okay, Ritika?
No, 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 sir. I was saying I got it.
Now, I'm going to start a very small topic, but since we have very less number of students, what I will do now, we have to shorten this particular class so that not very large number of people may get affected. Okay. So right now, you may think I'm flying, but maybe the student who is absent is you some later time. Okay, so you will have to cover less portions from the recording. Okay, so we will have like 20 minutes, 1 hour class. Now, just give me a second. Okay, so let's start a very small topic, that is Van Hoff factor. Now, there are various definitions of Van Hoff factor that we are going to look in the later classes, but right now you are going to understand how to determine the Van Hoff factor or the I, what we say as. Okay. Now, I will do a few questions, okay, and we are going to do the other questions. It's going to be very easy. If you know how to dissociate things, you can do that. Now, as he aa jayega, but you don't have to teach something new. So questions इससे सीधा समझने की कोशिश करेंगे. Determine the value of. Don't worry. Okay. Determine the value of. Please write this question with I for following. I से remove करते just one for fact. I for following. Determine the value of I for following. Number one, आप लिखिएगा. For example, NaC. What you will do, you will dissociate the NaC. So it will become Na positive plus Cl. Now, the value of I, how many species are there after dissociation? Tell me, guys. How many ions are there? जोर से बोलेंगे, please.
Two.
And before ionization, how many species is present?
One.
One.
So 2 by 1, that is equal to 2 only. Right? I will be equal to. Secondly, let us suppose I have MgCl. Mg will dissociate into Mg, positive, plus I will get 2 chloride ions. Now tell me, how many ions do we have after dissociation?
3.
How many?
3.
Okay, Amarnath, Mariam.
Sir,
After
3.
3, na? Because 1 Mg, 2 chlorides. 1 Mg. Yes, sir. Yes, sir. नहीं बोलिए Mariam. Answer कीजिए आप. Is your mic not working, Mariam? Mariam, क्या आपका mic काम नहीं कर रहा है? नहीं काम कर रहा. So I क्या है आपके पास? After dissociation, we are having 3 और पहले के पास 1. So I is equal to 3. Thirdly, let us suppose you have H2SO4. Okay, so you should just understand how these things are going to dissociate. So you will get 2 K positive ions plus you will get 1 SO4 2 negative ions. Sulfate ion. So I will be equal to 2K plus 1 sulfate, that is equal to a total of 3. Does this make sense? Yes or no? Please tell me.
Yes, sir.
What about others?
No, sir.
No. अच्छा, first of all, you tell me. I समझ में नहीं आया, ये समझ में नहीं आया, like the dissociation.
Oh, sir, I thought, sir, I have no doubt. No doubt.
अच्छा, you know that. I'm really confused. I am like struggling with this. हम दोनों ही सवाल हैं. Did you understand? And do you have any doubt? ये तो बच्चा कुछ नहीं, yes sir बोले कि मुझे बोले. That's what happened, I guess, right? Amarnath?
Sir, your voice
Just
is a
give me a
bit
second.
faint, sir.
Just give me a second, guys. Yes, am I audible?
Yes, sir.
So next, अब रेस्ट आप लोग कीजिएगा, ठीक है? ALCL 3 फिफ्थ में आप कर लीजिए. और क्या? Yes, yes. Thank you. Just give. You get the email and then send your answers on WhatsApp. Okay, guys, please hurry to send emails. है ना? ऐसा बिल्कुल. अच्छा, सुफियान ने भेज दिया. Sufyan, I would really like to see how you have dissociated things. Okay, so can you send it on my WhatsApp, Sufyan?
Uh,
It's
okay. Should I send a picture?
yeah. Send me a
Okay.
photo, like how you have done this. Dissociation.
Okay.
Amarnath, again, I would really like to see how you have done things, not the direct
Sir,
answers.
can you send your number?
My numbers. 7. Let's just give me a second. We need to add the plus 9 ones. 91753099880007. Okay, don't save this number. A better way of getting to WhatsApp is send this number to your mom or dad. Then this number will appear in blue. Tap on that blue part. It will say chat with plus 91753099880007. Tap on that chat with, then send photo. Okay, Manat. That's what I've seen as thing. So the number that will get WhatsApp. What I said, yes or no?
Sir, your voice was lagging or it was very faint. I couldn't hear.
Wait, do I need to repeat myself? Should I repeat myself, Amarnath?
Yeah, please, please.
Send this number to your mom or dad. This number will appear. Take a tap on that blue part, blue number, and then it will say chat with plus 91753099880007. Tap on that chat with 7. Okay, and then send the photo. Sufyan, I'm waiting for your photo. Sufyan,
Yes, sir.
Mariam. Yes, I've got a 5 right. Is that you? Okay, this is Amarnath. Amarnath, that was quick, right? Rather than saving the number.
Yeah.
ALC3, okay. ACL, correct. It was a 4, correct. Oh, that is, look at the calcium chloride question number. Can you see the calcium chloride?
Yeah.
If you look how you have dissociated, it looks more like Cu2 plus rather than Ca2 plus.
Sir, I was just writing it a bit, roughly.
But you don't do fair, or do you do rough and then you do fair?
Okay, I'll send you the
No,
file.
no, wait a second. You first write things in rough and then you write in fair copy.
Okay, sir.
No, I'm asking you, do you do this? Do you first of all write in rough copy and then you write everything in fair copy? Like you have 2 notebooks for chemistry.
No, sir, just this is like a tuition, right? So the tuition one will be, there's only one.
There is one notebook and you're writing everything that I am teaching. Correct?
Yeah.
So you have one notebook for chemistry for tuition, one notebook for physics for tuition, one notebook for bio or math or study for the tuition. Correct?
Yeah.
Okay, I'm still waiting. Mariam Batul, I'm still waiting. Mariam, what happened? Yes, Mariam, आपकी आवाज नहीं आ रही. Sufyan, time लगेगा क्या आपको? No, Mariam, I cannot hear you.
Taking the picture.
Sorry, what? What, Sufyan?
I'm taking the picture.
Mariam, I can't hear you. Please send the answer on my WhatsApp.
So I sent it.
Yeah, I just want. I'm going to check the कैसे इसे. And it was for the 3. It was for the 5. And 2 positive and so 2 negative. So let me do this also. So for AlCl3, I will write aluminium 3 positive plus I will have 3 chloride ions. This will be I is equal to 4. A positive plus Cl negative. I will be equal to 2. 2 sodium positive plus SO4 2 negative. This will be I is equal to 3. Al2SO4 will press. There will be 2 aluminium 3 positive plus 3SO4 2 negative. This I will be equal to 3 plus 2, that is equal to 5. Calcium will be 2 positive, plus there will be 2 chloride ions, which will be equal to I is equal to 3. Here we will be having Mg2 positive, plus SO4 2 negative, and I will be equal to 2. Mariam, just copy this down. If everything is right, please raise your hand once you are done writing. So, Sufyan, you're also done, right?
Yes, sir.
So, I will end the class here. Okay. And we are going to continue with the. This is actually the part of normal molar quantum fraction. So we have just one class remaining. Basically, होता है कि आज हम आपको थोड़ी सी theory पढ़ा फिर Wednesday I will have taken the numerical parts, but what we will do is we will take the same class a bit long and we'll complete थोड़ी कुछ ज़्यादा नहीं बहुत हल्की थोड़ी बट आप लोगों को गुजारिश ये है मरीम बतूल एंड अमरनाथ कोई शिकायत नहीं, they come on time. Mariam Batul, please be on exact time. If you're having difficulties in connecting, then please try to make sure that you come to the next class 5 minutes before. Okay? Because if you are going to miss the initial part of theory, you will not be able to confidently understand the latter part. Okay? This is very important. Okay? Mariam Batul, can you make a promise to me? Yes, Mariam Batul, tell me.